Today, I'm going to talk to you about probability, and there are two different ways of finding it, the area model or the tree model. I'm going to show you the tree model. First, we need to know that with probability, there is a chance, it's not a prediction, there's a chance that something's going to happen or it's not going to happen. So if something is 100% going to happen, there's a 1 probability chance. It's going to happen no matter what. So the sun will rise every day. That is a 1 probability chance, 1 out of 1. Something that's not going to happen, never going to happen, is going to be me going a whole day without blinking. That is 0 probability that that is going to happen. So we need to remember that probability is not a prediction. Something will or will not come out of the probability. So for example, the dot stands for something that's going to happen. So every time a new thing happens, you're going to have the dot and it's going to stem off. So let's say we roll a fair-sided coin. So there's heads and there's tails. There's only 2 sides. Well, something is going to come up. So you have heads or tails. So H equals heads, T equals tails. We have our thing happening. We label both sides. And there's going to be a 50% chance, half and half, that you'll get a heads or a 1/2 probability that you're going to get a tails. So that's just a basic example. There's plenty of good things to use a tree model for. It's easy to see. You can see the order of events. It's easy to go off of. And it's always doable, unlike an area model. So to use a more complex example, let's say Bit is playing basketball and she gets fouled. When she gets fouled, she gets to shoot 2 free throws. So, and every time she shoots, there's a 60% chance that she's going to make her shot and a 40% chance that she's going to miss. So we all know from math already that 60% equals 60 over 100. So 6 out of 10. Same with 40%. Okay, so we have our event. We are finding the probability that Bit scores 2 points. In basketball, and when you shoot free throws, you can either miss both, you can make one and miss the second one, you can miss the first one and make the second one, or you can make both. So, the probability that Bit scores 2 points. So we have our event, and on the first free throw shot, we know that she has a 60% chance of making it, so 6 out of 10, and then 40% chance that she misses. So makes, misses, and that's the first one. Then she gets to take another shot. So we had another dot for another thing that happens. Not always, it's not called an event. So another dot. She has a possibility of missing it again, or making it. Missing it or making it. And the probability does not change. She always has a 6 out of 10 probability that she's going to make it. Same with missing. She always has a 4 out of 10. Now, in order to find the probability of Bit scoring 2 points, we have to follow the line that goes from makes to makes and multiply those two fractions. So we have 6/10 times 6/10. So 36 over 100, which simplifies to 9 out of 25. And this is the probability that Bit scores 2 points. Now, if we were to ask what is the probability of Bit making 1 point, we would have to make sure to follow both. So if she misses the first one, she can still make the second one. If she makes the first one, but still only gets 1 point, she misses the second one. So we do 4/10 times 6/10. And then we have to add that probability to the probability that she makes it and then misses it. So 6/10 plus 4/10, or times 4/10. So over here we're going to have 24/100 plus 24/100, which equals 48/100. And that's the probability that bit makes, or bit scores 1 point. So as you can see today from our lesson, tree models are nice and easy to follow. It does get a little congested when you have a lot of numbers or a lot of fractions, but for problems like these, it really works well. Hope you learned something today.